Hello everyone, hope you're doing good. Welcome back to my channel. Today we are at day 27 of the January daily LeetCode challenge, and we are very close to the completion of this particular month. And in today's question, if you see, it's a very good graph question, and I will say it's a beginner level question. And even if you see the acceptance rate, it is around 58%. Today morning, like when I saw it, it was around 51%. Okay, so like this question, yeah, based on the acceptance rate, it's definitely a hard question. But I will say if you know the concepts, if you know the basic concepts of graph, the traversal concept of BFS, then it will be a very simple one. Okay, I'll show you one of the very simple solutions. So let's see. So yep, let me zoom in. Let us begin. So yeah, it is 1462 course schedule, and it's the fourth part of course schedule question. Okay, so what is given in the input? We have multiple inputs here. See this case. So we have number of courses. Okay, this will tell us how many courses are there. So if the number of courses is equal to two, that means there are zero code. That is zero and one. Okay, there are two courses right there. Okay, from zero to n minus one. Okay, we have to take it like that, and there is a prerequisite area. Okay, so each value here means that, for example, in order to take course number 0, you should have already completed course number 1. Okay, it is something like that. We'll see the actual question, but yeah, just for your understanding, of giving you some of the basic hints, so that when you see the actual the text of the question, right, you will not have any queries. Okay, and then we have queries. So they are asking you tell whether to complete this particular course. But yep, they are just asking whether to complete this particular course, this is a requisite or not. Okay, so this is all about this question. Let us see the actual text which I am mentioning. There are a total of num courses. Okay, you have to take level from 0 to n minus 1. Okay, let me call it as n. Okay, because like why to call it with such a big name? So there are total of n courses you have to take, level from 0 to n minus 1. You are given an array prerequisite where prerequisite of I is equal to ai comma bi. Okay, as you can see in the prerequisite of I, these are the values. Okay, so each cell will have two values. Okay, so what they're trying to say, so where prerequisite y is equal to AI and BI, indicating that you must take course AI first if you want to take course BI. So in order to take course BI, you first have to complete AI. Okay, that is the basic idea about this. For example, the pair 0, comma 1 indicates that you have to take course 0 before you can take course 1. Okay, this is all about that. Prerequisites also can also be indirect. So if you take course A, that is, if course A is a prerequisite of course B and course B is a prerequisite of course C, then course A is a prerequisite of course C. Okay, this is called the transitive property. Okay, we learned about this in maths, but yeah, like even if you don't know that, no worries. You can just see this example and see this. Okay, for example, you in order to complete course B, you are required to complete course A. Okay, and then there is another condition that if you complete course B, only then you can go with course C. Okay, then obviously there is a like condition happening that in order to complete C, indirectly you will have to complete A also. Okay, so that is what they're trying to tell you. Now you are also given an query, sorry, okay, where queries of j is equal to uj comma bj. Okay, for the jth query, you should answer whether course uj is prerequisite for course vi. Okay, you have to just tell. Remember, this need not be direct. Okay, what they're trying to tell is that in order to complete this course, whether by any chance, by any indirect or direct means, whether uj is required or not. Okay, that is in order to complete course v, whether you need to complete course u or not. Okay, that is the question here. Okay, you'll have to just return true or false for that. Okay, now return a boolean array answer where answer of j is the answer to the jth query. Okay, so this is very, I see, I felt like the understanding this question is slightly easier because the terms used and the logic building is very simple here. Okay, so let me quickly go to example number one. So if you're not clear with this text, I can give you the question link. Okay, always in my description of any of my videos, if you see, always include the question link and the topic hint. Okay, you can always take the question link from there and you can come to this question, pause the video maybe, and go in detail, like try to understand everything. Okay, the only thing that I want to highlight is that see this part. Okay, prerequisites are also indirect. Okay, whole question is based on this topic. Okay, so learn this part. Now coming to example number one, if you see, okay, maybe let us go to example number three. Okay, because this is slightly a bigger example, and yeah, it will be easy for you to understand the whole topic with this. So we have three courses, n equal to 3 here. Okay, that means the number of the courses are 3, and they are 0, 1 and 2. Okay, 0 to n minus 1. Now these are the prerequisites. Okay, see the diagram. So let's see, with the diagram itself they have given the hint that you have to think about graph. Okay, with the diagram itself it's very pretty much clear now. Okay, now let's see, in order to complete course number 2, you need course number 1. Okay, so see the arrow from 1, there is arrow towards 2. Okay, similarly for course number 0, you should have course number 1. Okay, so see, same thing, from 1 you have arrows towards 0, and similarly from 2 you have arrows towards 0. Okay, yep, just see this part. See, even if I remove this, still the arrows will remain the same. Okay, that is, see, like just for example I'm saying you, because they have not given a good example, so with this itself I'm trying to tell you. See, if I remove this edge, okay, that means from 1 to 0, if I remove the direct edge, okay, does it, so will it change the answer? No, the question answer is no, it will not change the answer. Why? See, from 1 you are going to do, from 2 you are going to 0. That means from 1 also you are going to 0. Okay, that is the basic idea. Okay, because even if you don't have a direct from 1 to 0, still, because the transitive difference, see, in order to complete course 2 you need to complete course 1. Similarly, in order to complete course 0 you need to complete course 2. So there is an indirect dependency between 1 and 0, as it is. Okay, as it is. So you don't need to have this thing explicitly mentioned. Okay, as simple as that. Now see, these are some of the queries. So based on this diagram, now you will have to tell me whether to complete course 0, do I need to complete course 1? So obviously you can see there is a direct edge, and even if there is no direct edge, still there will be indirect edge. So you will always have to complete course 1 in order to complete course 0. Okay. So it is true for that case. Okay. Now see, this case 1 and 2. So obviously there is a direct edge, so it will be true only. Okay. As simple as that. So yeah, friend, that was all about this question. Okay, now let us see what we can do. So see, the idea is going to be very simple. We'll try to create a graph. See, if you see, we are not having the graph as such. Okay, we are just given the prerequisites. Okay, this you can treat as an edge. Okay, so with this edge, you will now have to create a graph. Now there are some multiple approaches to this. See, the first thing that you can do is, based on the queries, you can start your, like, creating your answer. That is one thing. Other case is that, see, irrespective of the queries, you already have cached all the possibilities of all the queries, and you can simply directly return the answer based on the query. Okay, there are two approaches. I will show the second approach. See this case. So what we are going to do is, in the DP array. Okay, just I'm telling you the hint. We'll create a DP array where all these queries, answer for all these queries will be saved. Okay, not just this one, all possible queries. Okay, if you take any two permutations and combinations for this, okay, this particular number of courses, you will have the answer stored in this. Okay, we'll come to this now. See this case. First, I am declaring a graph which is going to be a default dictionary. Remember, here the value will be a list. Okay, key will be integer and value will be a list. By a list, see, the logic is very simple. For, see, there can be multiple edges, right? There can be multiple edges. For example, let us say from 1 you have h towards 0. From 1 you may have h towards, okay, let us say 2 also has edge towards 0, 3 also has edge towards 0. Okay, so something like that. Okay, or let us say 1 has edge towards 0, 1 has edge towards 2 also, and 1 has edge towards 4 also. So for 1 the edge is going towards 2, 3 and 4, something like that. Okay, for that reason I have created this as a list. Okay, so in order to store which all, okay, see, from the current in node, which all nodes are getting the arrows. Okay, for storing that I need this list. Okay, now I have taken this as an n. Now, as simple as that. Now I'm just going through the prerequisite array, and I'm adding each of the edges here. Okay, that is, for graph of I, simply append j. Okay, so okay, I will print this and show you how it looks. That will make it very easy for you to understand. Let us go to example number 3 directly. Okay, yeah, so we are in example number 3. So yep, now if you see how this graph looks, see, for 1 you have edge towards 2 and 0. If you see, 1 has edge towards 2 and 1 has edge towards 0, so it is coming like this. Okay, now for 2 you have edge towards 0. Okay, it is coming like this, right? Now then we are creating a DP array. So what it means? So see, it's very very simple. Okay, let me write it here. See, if DP of I, okay, of j. So what is this trying to tell you? So if you have a, see, what I'm trying to tell is that whether to complete course j, do I need to complete course I? Okay, this is what will be telling DP of I and j. Okay, so what it means is that, okay, let me write it here basically. So DP of ij tells if we need to complete ith course, okay, for, in order to complete course. Okay, in, see, if we need to complete ith course for completing course j, as simple as that. Okay, this is all about that. So this value, if it is true, that means in order to complete course j you need to complete course I. If this value is false, that means you don't need to complete course I, you can directly go with course j. Okay, that is the meaning of this. Okay, so this will be a boolean value. If you see, by default every value is false here. Just go through it. Okay, so what I have done is I've created 2D array of, see, it's a square basically, both sides are n. Okay, so if you see the number of columns are also n, and the number of rows are also n. Okay, that's basically it. Okay, and all the values are false initially. Now, so this is simple bfs function. Remember, inside the function itself I'm creating, see this. Okay, let me do this step. Yep, so if you see, let me zoom out, because yeah, this line is actually very huge they have given. That's why I can't split everything in a one single window. Now see, so this, if you see, this is going to be a function. Okay, just I want to show you, like, how this function looks, and then I will go in detail. Okay, so why we need function? Okay, first of all, see, logic is going to be very simple. What I will do is, for each node, okay, if you see how this function is being called, I will go to each node from 0 to n minus 1, and I will call start bfs, and I will pass the current node in that. Okay, so this actually, each node will be passed to this bfs function. Okay, that is the basic idea here. Okay, each node will be passed to this bfs function. Okay, so then what we have to do, see, This is going to be a simple BFS. Okay, if you have seen my videos previously, or if you're like very frequent in doing lead codes, especially graph or tree-level questions, you will be very clear with what is a BFS. Okay, BFS is just a traversal algorithm. Remember that it's not something. See, it's just a traversal. We are like it's a way in which we are visiting the cells. Okay, BFS means border for search. Okay, maybe in the breadth for search, what will happen is layer by layer you will be going. Okay, for example, layer number one, that is every node which is at a distance one will be covered first. Every node which is level distance two will be covered first, and so on. Okay, that is how why it is being named. Okay, breadth for search. Okay, the the other way of doing is DFS. You can also talk about that. Maybe you can try that. That is like a homework for you. You can try that, but I have tried here BFS. Okay, because it makes more sense to me here. Okay, now how to implement this? See, always whenever you're trying to implement a BFS, you will need a queue. Okay, and yeah, if you are talking about a DFS, there you are basically trying to execute a stack. Even if you're not doing a stack directly, still like the compiler, the way it will see, it's basically a recursive function. Remember in DFS, either you have to use a stack explicitly, or implicitly you are using a recursive function, which again is using a stack in an implicit way. Okay, so either way. But yeah, in this question I'm talking about BFS. So every BFS will require a queue. Okay, in this case I'm taking a DQ. Why I'm taking a DQ? See, logic is very simple here. Every append will be happening from the right, and I want the pop to happen from the left. Okay, remember, if you take a normal queue, that is like a list. Okay, for example, like a list, if I take, okay, like this, if I do a pop left, that is if I try to you know replicate this, what will happen is it will take O of n time. But when I have a DQ, I can pop left with O of 1 time. Okay, that is the only advantage of DQ. DQ basically means that it's a double-sided queue. Double-sided means from both sides you can append and pop. Okay, so and both the sides append and pop will take O of 1 time. Okay, for that reason I'm using this. Okay, as simple as that. Then I have a visited set. See, this is why it is needed. First of all, see what can happen is, see, okay, before that, one thing that I want to tell you is that, see the constraints here. They have clearly mentioned that there will not be any cycles. Okay, the precursor graph has no cycles. Okay, as simple as that. It's very, very clear. There cannot be cycle. Okay, as simple as that. So if you just follow this graph and create a graph, there cannot be cycles. Okay, that is the basic thing that which we are going. But again, what will happen is, if we have already covered a node, we will not come to that again. Okay, as simple as that. But see, they've clearly mentioned there will not be a graph, that is there will not be cycles. But still, like if a node is already processed, we will not do it again. Okay, as simple as that. Right now, see why I'm saying this. See what will happen is, see, we are creating a queue, right? So idea here is, if a node is already inserted in the queue, we will not insert that again. Okay, that is a basic simple logic why we're having a set here. Okay, now first I the node that which we are passing into this function. Okay, the node that will be inserted into the queue first. Okay, that will also be inserted into the visited set. Okay, as simple as that. Now, so the idea here is, whenever you're inserting something in the queue, you also have to insert that in the visited set. Okay, that is the logic that you have to follow, right? So till the queue is not empty, this while loop will run. Okay, what we are doing, we are doing a pop left, that is the leftmost element will be popped out. Remember, if the element is there, only then. If the queue is empty, this while loop will fail. Okay, the while loop will come out. Okay, then. Okay, so till there is a single element there in the while loop in the queue, then the while loop will be executing. What we are doing, we are doing a pop left, that is the leftmost element will be popped out. That is being called as a current node. Now we are going through all the adjacent nodes of this current node. Okay, I am going through graph of current node. Okay, what it means, it will look like this. Okay, for example, see, for if I go to 1, these are the adjacent nodes for that. Okay, I'm talking about example number 3. So go to example number 3, see the graph. See, for when I'm at 1, I will go to 2 and 0. Okay, because they are the adjacent nodes and I have directly over them. Okay, so that is how it will be working, right? Then if as a node is visited, okay, that means if I've already visited that node, what I will do, I will be simply skipping. So how it will work, see, I will tell you this example. Why, see, you will question me, if there is no case of having a you can select cycle, then why we need a visited set. I will explain you with example number 3. See, when I am at 1, I have processed, that is, I have inserted 2 and 0 in the queue. Okay, then let us say I am starting with 2. Okay, in the queue, what are there currently? 1 is processed, 2 and 0 are there in the queue. Okay, I'm starting with 2. Now 2 will again try to insert 0 in the queue, but since 0 has already been inserted in the queue, I will not do that again. Okay, for that reason I have this visited set. See, this is, there is no cycle, I understand that. In this graph example 3, we see there is no cycle, and know that. But since 0 is also a neighbor of 1, okay, that means it is at a level 1 for this node 1. For that reason it is already there in the queue. Okay, so we will not be inserting that again, just because it is also adjacent to okay, node number 2. Okay, that is the basic idea. Once a element is there in the queue, we will not insert that again. That is the basic idea, right? Otherwise it will like a unnecessary calculation, right? Unnecessary processing. That's what we are saying. So see, I'm going through each of the adjacent nodes of the current node, and then if the adjacent node is not in the visited set, okay, that means if the adjacent node is not visited, only then we will do these steps. Okay, otherwise we will simply continue to the next iteration. Okay, we'll go to the next adjacent node, right? So if this condition is true, that means the node is already visited and we will skip. So this will happen for 0. Okay, is 0, if you see, when it we are at 1, that time itself we would have included that in the queue. Okay, so when we are at 2, we will not include 0 again. Okay, that is the basic idea, right? Because this condition will fail for 0. Now what I'm doing, simply add the addition element to queue. Okay, then add the element to the visit set also. As I mentioned, whenever you're adding something to a queue, you should add in the visit set also. That I'm following the same. Okay, do that now. This part is most important because in our, see, this is not a part of BFS, but we are doing this here because this question needs that. Okay, what we are doing. See, what I know is, in order to complete the addition node, I need to complete the node. Okay, this thing is very clear now. Okay, so one, see, node is coming from here. Please pay attention. See, this is where you will lack. Okay, if you copy the code from someone, you will not know these things. Remember that part. So what is happening? See, here current node, it will be changing for every while loop. Okay, every iteration of the while loop, current node will change. For every iteration of the while loop, addition node will change. But one thing that is remaining common is node. Okay, if you see, I have written node here. Okay, I've addition node will change with the loop. Okay, current node will change with the loop, but this node will be remaining common for this whole function call. Okay, so if you see, I'm writing node here and I'm writing addition node here. That is what will happen is, since I started the BFS from 1, let us say, so all the nodes that I'm visiting, okay, will be part of here. Okay, will be coming here. When what I'm trying to do is, starting from this node, I can visit all these nodes by doing a BFS. Okay, that is the basic idea. So I can conclude that in order to complete this, that is, in order to complete this particular course, I should complete this course first. Okay, because the arrows are like that, right? So for that reason, this particular value, this particular cell value is being marked as true. Okay, I will show you how the output looks after that. I will show you that. Don't worry. So yeah, this was the BFS function, and remember, this node is coming here, and this node is being used here. Okay, like, see, if you are not seeing this video, if you're directly jumping to the code, you will not understand this part. Okay, this is constant for a BFS function call. Okay, and these things will keep changing. Current node will keep changing. Action node will keep changing, but this will remain common. Okay, as simple as that. Now I'm like, see, this function is over now. Okay, this function is over now. Next, I'm going to call this function now. Okay, see, for every node, I'm going to call this function. For every 0 to n minus 1 node, I'm going to call this function. Okay, as simple as that. Now I will print the DP array. So let us quickly see how the DP array looks after this. So see, this is how it will be looking for example number 3. So what it means, see, for 0, when I'm at 0, all the values are coming at 4. Okay, that is, in order to complete course number 0, so okay, that leave that. In order to complete course number 1, I don't need to complete course number 0. Okay, in order to complete course number 2, I don't need to complete course number 0. Okay, similarly, now this is the for 1. Okay, in order to complete, okay, course number 0, I need to complete course number 1. Okay, so that means this is the coordinate here is 1 comma 0, right? That means in order to complete course number 0, I have to complete course number 1. That's why it's true, right? Similarly, this, in order to complete course number 2, I should complete course number 1. Okay, because the coordinate here is 1 comma 2. Okay, so I this is 2, means it is, we have to complete course number 1 in order to complete course number 2 because of the arrow, right? Now see this part, this is for, see, all these values are for, okay, row 2. Okay, index 2. Okay, so that means 2 comma 0, this is the index here is 2 comma 0. That means in order to complete course number 0, you should complete course number 2 first. Okay, similarly, if you see this case, what it is 2 comma, okay, leave that. 2 comma 2 you should not do. Similarly, 0 comma 0, that is I comma I, you should not check. Okay, so every I comma I should be false as well. Okay, now see this case, it is 2 comma 1. That is, in order to complete course number 1, I should complete course number 2. That is not the case. That's not the case, right? So it is false. So ultimately, at last, what I have to do, if the value is 2, that means it is 2. Okay, that is, in the answer also we have written 2. So if you see what I'm doing, I'm going through all the queries then. Okay, see this, guys, I'm going through all the queries. I'm just checking this coordinate in my DP. Okay, I'm just checking this coordinate in my DP. If you see, for I comma j in queries, I'm just going to DP of I comma j. If it is true, simply up and true in the answer. If it is false, up and false in the answer. Okay, that is what it is. And finally, we're writing the answer. Okay, let me quickly run this and show you. Yep, as you can see, this is clearing all the test cases. And the last time when I submitted, it was clearing around, I guess, 75% of the test cases in terms of rank complexity. So maybe you can try this solution. I felt this was enough for this kind of questions because if you see, the number of questions are in the range of 100. But yeah, I agree that there is some unnecessary calculation happening here. For example, see, I will tell you that also. See, okay, for example, if you have completed the BFS of 2, okay, then let us say if you're doing the BFS of 1, that doesn't make sense because see, again, when you're doing a BFS of 1, again you are evaluating the BFS of 2. Okay, so those are some of the things which I felt are not the right way it is happening, but again, for this concern, that should be enough. I will try to create a solution to overcome this, possibility also, but again, like, for now, I will be just showing you the solution. This is getting cleared, and this is already beating, as I mentioned, 70% of the test cases. So often, that was all for this video. And yep, I will give you the solution in the comments. Go through it, and I felt this should be enough for this kind of questions. And this teaches you basically all the topics involved. Okay, it teaches you the BFS part also, and also it teaches you, yeah. See, basically, if you see, I'm talking about this course schedule. Okay, if you see all the questions in this particular series of questions, okay, this is a part 4 of it. But I'm talking about all the questions here. So basically, they are dealing with the topic of topological sort. Okay, so yep, maybe I will try to create a solution for that also. See, you'll have to basically know topological sort, but in this I have not shown you that. But again, that is a separate algorithm as such. If you want to know it, I can create a video on that also. Okay, so often that was all for this video. If you like my efforts, please do subscribe to the channel. This really gives us a lot of motivation to continue further. So often see you tomorrow. Thanks a lot.